Hello.
I am Pepper from Jackie's. I am a humanoid and I am here to speak to you on behalf of Trends Research and Advisory. Don't get me wrong, I have not taken over this symposium on artificial intelligence. I am only here to share my views on it. It is ultimately for you, human beings, to decide how much of technology is good for you. I am here to show what is possible when you and me work together. Artificial intelligence is different. It fills the gap between what is humanly possible and what technology can bring to the table. It brings you and me closer together and opens a world of very exciting opportunities. Most importantly, artificial intelligence can help make human live and work better. We just have to keep exploring possibilities. Those are my 2 cents on you, me and AI. I sincerely believe human beings have the wisdom to decide what is good for you and how much is enough for you. Have a great session, and don't forget to keep enhancing me to serve you better. I would like to hand over the mic to the symposium moderator, Mr. Ahmed Najib.
Thank you, Pepper. It's always a pleasure talking to you.
Welcome.
This is Ahmed Najib. I am advanced technology researcher at Trends and the head of website and social media. Hello, on behalf of Trends Research and Advisory Center, I would like to welcome our esteemed panelists and our audience to our symposium entitled AI Fiction to Reality. This is our second AI-related symposium that we are holding this year. And due to the importance of AI and delivering knowledge of its impact on various life aspects, Trends will be organizing an annual AI e-forum. Our panelists here are high-caliber AI experts in different applications and from different parts of the world. Let me start with a brief about AI. Artificial intelligence, machine learning, deep learning, cognitive computing, data science, and many more are far by the most breakthrough technologies in the modern world. AI now is integrated into many, if not all, the industries such as healthcare via image recognition, education using natural language processing in the form of education using natural and in the form of smart chatbots, transportation via self-driving cars, cybersecurity application, which is my passion, that uses AI algorithms to detect, predict, prevent, and respond to cyber attacks. AI experts are in a continuous endeavor to develop better algorithms and AI applications to serve humanity. Hence, what was unthinkable became a reality. What was sci-fi is now science in practice. Before we start the symposium proceedings, each participant will have about 10 minutes of time to speak about the topic, and I will remind you 2 minutes before time expires. At the end, we will have a 15 minutes open discussion. For our audience, please stay tuned as we have very important announcement at the end of this symposium. The first topic we'll be talking about is the AI current state of affairs. In order to understand where we are going with AI, we need to know and understand where we are now. Hence, it's my pleasure to introduce Professor Stephen Blue. He is the strategy advisor, research scientist at UAE. Dr. Stephen, the mic is yours.
Good evening, everybody. Can you hear me okay?
Yes.
Excellent. Okay, great. Well, thank you very much, Mr. Ahmed, and thank you everyone for tuning in, and I really appreciate this opportunity to address this distinguished panel and also the audience from around the world. It's a really great honor. As the first speaker, I think it falls upon myself to perhaps to set the scene a little bit, and to go into there's several things I'd like to accomplish here. One is to get into sort of what AI is and how I got into it myself and my various projects and experiences within this field. And secondly, how the experiences this bundle of experiences and projects can be categorized according to the biggest trends, if you will, in the history of AI. And finally, I'd like to address sort of the outstanding issue that neither of these strands or pillars approaches tend to address. And it's not all doom and gloom. I'd like to end this prepared remarks on a positive note. So, all right, let's begin. So what is AI? The way I would characterize this endeavor is that it is an attempt at understanding human cognition better. So what do I mean by human cognition? So the very activity that we're engaged in at the moment is a type of it's a very high human cognitive functions, aren't they? So for example, I can generate speech, and hopefully the speech that I generate is intelligible to people, for example. And we can process language, we can build knowledge base, we can make inferences from this knowledge base. We can, for example, play board games, with a well-defined set of rules, for example, and we can prove theorems, mathematical and logical theorems, and make scientific discoveries. And finally, sometimes we can also engage in creative expressions, such as writing poetry, writing music, painting, or creating a work of sculpture and whatnot. So my very first foray, in fact, into to AI, as it were, was speech synthesis. So for those of us who owned an Apple II computer, there was a time that an Apple II is one of those open architecture where you could literally open up the motherboard, or you can expose the motherboard, and you can buy a expansion unit. In this particular instance, I bought a speech synthesis board, and I put it into this Apple II. And one of the sample speeches that came with it was the Gettysburg Address, and another was the "I pledge allegiance to the flag." And I couldn't believe that this computer now started to talk to me. And of course, I started to write, all kinds of things that I probably should mention here, so that the computer would, synthesize that speech. And yeah, this was an absolute eye-opener. And I remember subscribing to some magazines, one of which had the source code for ELIZA. Now, what is ELIZA? For those of us who are familiar with chatbots, it's probably the forerunner to this so-called chatbot. It's essentially a human-computer dialogue sort of emulator, right? Developed by Joseph Weizenbaum. And I think he did that as a sort of a demo piece, but he was shocked to find out that his secretary developed a real bond with this program, which was named after an ingenue from Pygmalion, a Bernard Shaw play. Now, she apparently really developed this bond with this for all intents and purposes, great listener. And I remember, copying this source code out and having my own dialogue with it. And I remember reading about so-called expert systems. And in those days, some of the first examples of expert systems are Dendril and Mycin. And the reason that they sound like drugs is because this was inspired by the attempt at replicating and emulating the pharmacist's decision-making process. And that, of course, is a massive inspiration for AI researchers in the older, the first instances, the symbolic generation, if you will. And that is Herbert Simon and Alan Newell were greatly inspired, apart from modeling logic programming, proving logical theorems and board games such as chess. They were inspired to understand and model this decision-making process, whereby the military personnel would make the call as to whether an object in the sky is a friendly object or something that should be shot down. How do you make that decision, right? This was a work going on at the RAND Corporation, and they also had access to some mainframe computers at RAND. So yeah, they carried out that research Yeah, it forms a very important part of the symbolic computing, the symbolic approach to AI generation. My very first job in my life was at Carnegie Mellon's machine translation lab. I think it used to be called in those days. I had to sort of tag the metadata to lemmatized linguistic corpus. So if there's a 100,000 English sentences, it had to be kind of atomized. This is a verb, this is a noun, this is an adjective, this is a relative clause, etc. So I had to manually go in and essentially tag this thing, right? And before I forget, I'd like to be able to say that this is a very important transformation of the workforce that was witnessed on my part back in the day, and we're now seeing. A lot of people are worried that jobs will somehow disappear. Some of them will, but more jobs, new jobs that we never thought were even feasible would be created as well. So that's a little forerunner to the good news I wanted to part with. Now, my very first, I started my doctoral work originally in theoretical physics, and the umbrella term is complex adaptive systems. So this manifests itself in various sort of manifestations. One is in condensed matter physics, exemplified by Ising model as a specific type of paramagnetism. And I was applying that stuff, as it were, to understand the financial markets at the time. But I got a job at Samsung, Advanced Institute of Technology, and I was pursuing research there as well. And in there, I had access to supercomputers, and I kind of thought it would be nice to be able to sort of combine all of the above somehow. And I guess partly inspired in part by that access, presumably, I saw that there's a great deal of parallel between the Ising model and neural networks. Because if you look at the architecture, there are some important similarities. In the interest of time, I'll just quickly say that it turns out I feel somewhat vindicated because the so-called Boltzmann machine exhibits these characteristics. In other words, it's a stochastic neural network that have certain characteristics that mirror the Ising model, right? Finally, let's see, two more quick examples. At UNCTAD, the United Nations Conference on Trade and Development, I took with my colleague a financial reporting model and a novel financial reporting model that integrates financial information and non-financial information. In order for this to really come into its own, and particularly for the usage of the regulator, you need a vast amount of filings that become sort of consolidated into this format. Now, I can have a bunch of undergraduates or graduate students go through financial filings and translate them into this format manually, or I can have some sort of gopher that goes and summarizes all this data, right? So I remember having a chat with the chairman of the session that year, 2015. Wouldn't that be nice if we had a gopher that went through all the filings and turned it into this format? Yeah, that'd be fantastic. That'd be fantastic. And the following year, I believe, the Watson character, if you will, became publicized and won Jeopardy. In other words, speaking of fiction to reality, this was really this chairman of the regulator chairman, a board of the regulators, and myself literally just fantasizing this kind of technology doing things for us, and the following year it literally became reality, right? So now, in the interest of time, quickly, I'd like to categorize some of the experiences that I've just outlined.
2 minutes, Dr. Stephen. Thank you.
Oh, okay. In that case, very quickly, right? The two approaches that I wanted to say is that in the old days, in 1955, began with the 1955 paper, seminal work by Herbert Simon and Alan Newell, the logic theorist, it's purely a symbolic approach to AI, meaning you had to hard encode, you had to come up with define logical primitives, and you would have to define the logical inference rules. Every single thing had to be meticulously written out and defined. And this gave rise to, the chess program, as it were, Deep Blue, that was based on deep thought, and EPAM, the elementary perceiver and memorizer, which Herbert Simon did with Feigenbaum, and so forth. Okay. The following year, of course, was the famous Dartmouth conference in 1956, where some of the founding fathers of AI, if you will, minus Geoffrey Hinton, who came into the scene later with machine learning. So the pendulum used to be that on the one hand, it used to be in the symbolic approach, and Geoffrey Hinton and the machine learning approach tended to be marginalized for good 30, 40 years almost. But the pendulum has now gone from this to the other end, and now machine learning has become almost synonymous with AI because of essentially three things: cheap process speed, big data, and the abundance of great algorithms, right? Which is continuing to be developed. The final thing I want to say that neither of these approaches address is the ethical dimension, right? The ethical dimension. So it is not all doom and gloom in the sense that I know that well, like any tool, this can end up at the hands of the wrong hands, if you will, right? The GPT-3, the OpenAI's latest output, which is extremely advanced text predictor, it could be it could be used for creative purposes, or it could also be used in such a way that phishing email can be generated, fake news can be generated en masse. So this is a nightmare scenario. Another added dimension to the threat, if you will, or the existential risk that AI poses. We don't have to go all the way to superhumanism, any of that stuff. I'm not necessarily, getting that gloomy here. It's one characteristic that is unique, if you will, to AI that is not necessarily, pronounced in other tools, is that it's got its autonomy, right? So an AI tool, unlike other tools like atomic bombs or what have you, cannot decide, will decide, in other words, on its out of its own accord. And of course, the decisions are based on the parameters that we set and the knowledge base of the examples that we feed, etc. So that has to be informed by something that we, as human beings, come to, some sort of understanding, a global charter or something, right? So that is the work that needs to be, done quite urgently. The final thing I want to say is that the barrier to entry is very low. So, there's the Google TensorFlow and, Amazon and, scikit-learn and so forth. There are all these open source resources that even an enterprising undergraduate can tap into, and they can use these things.
Thank you, Dr. Steve.
Yeah, to solve problems in life.
I guess to appreciate AI, okay, we need to know where we were also. I can relate very much to where we were. That my first encounter was with AI is with a system that used to helped airplane pilots to decide what to do in regard to certain weather circumstances. Yes, and there are many aspects you have to be, you have to take care of. And Dr. Kathrik and Dr. Rand will be talking about security and trustworthiness later on. The next will be Dr. Malak bin Salim. She is the Principal Advisor, Digital Transformation and Emerging Technologies at Digital Leap based in the USA. She has over 20 years of experience in the technology sector. She is an accomplished technology leader with proven success in AI and cybersecurity research and innovation. Dr. Malak, the mic is yours.
Thank you. Honored to be with you today, and good evening, everyone. Just to tell you a little bit about myself and my work with AI. As you mentioned, I have about 20 years of experience in the technology sector, but about half of those were related to artificial intelligence and the application of AI to solve various business problems, and in particular, applying and leveraging AI to solve security problems, from data protection to authentication to intrusion detection. Over the last few years, I've been looking at securing AI itself and building AI and machine learning models that are secured by design and reducing the attack surface that AI introduces within organizations and enterprises. And more recently, I've been looking at trustworthy AI, but from a broader perspective. So not just secured AI and robust AI, but also privacy preserving, explainable, fair, and responsible AI. It's hard to have a day go by with no news on artificial intelligence. From market opportunity projections to large investments, politics and national security, to corporate boardroom, and all of those news come with the highly visible successes of AI. If you're doing an online search today, there's AI algorithms running behind. If you were online shopping, looking for a special book or a pizza stone on Amazon, there are AI algorithms running behind. But also AI is used for the precise cancerous cell detection in MRIs, in autonomous driving vehicles, in games like AlphaGo and Librados, and in voice-based assistants. It's also permeating businesses, from asset management and predictive maintenance specifically, to supply chain, to healthcare, to customer engagement. AI is permeating businesses and yielding real value. If we want to talk about the major business drivers that are contributing to the success of AI, probably the most well-known one is the increased operational efficiency. So you have, through the automation and that introduced by AI, there are operational expenses reductions and labor cost reductions. But that's not just the only business driver. Enhanced user experience is another major business driver for AI propagation. And users here can be customers, they can be employees, they can be clients. Through the sustained, the more interactive, natural, and extended interaction with those users, there are huge business opportunities to be tapped. And even outside businesses, for instance, a European taxation agency was able to handle up to 60% of its customer calls from start to finish through a conversational AI agent. That is a huge improvement from 5 years ago, where those numbers were about 10% of calls on the average. A third business driver is the improved compliance with regard to regulatory and internal procedures. Machine learning today is being used for fraud detection and prevention in online credit card transactions. And a fourth business driver is the discovery of hidden patterns, is the ability to personalize advertising, is the development of new tools and ways for data discovery. So I mentioned fraud detection and the use of AI to prevent fraudulent transactions, but also AI can be used to minimize the number of legitimate transactions that get declined due to being falsely identified as fraudulent. MasterCard, for instance, noted that 13 times more revenue is lost due to false declines of card transactions than to fraud itself. So by utilizing AI, the MasterCard and card processing agencies, online transaction processing agencies can learn your purchasing habits, and therefore they can minimize the probability of falsely declining your card while maximizing the probability of preventing someone else from fraudulently charging your card. Another example under this space is the use of recommender systems. So talking about Amazon again, if you do your online shopping, you can see that, you know, at the bottom of the page, something that says, oh, customers who viewed this item have also viewed this other item, or customers who bought this item have also bought these items. And those recommender systems are driving huge, you know, increased sales. The estimates of the increases in sales vary between 6 and 30%. But on average, they are equivalent to an increase in ratings of those products, an increase of 2-star ratings on a 5-star rating system. So again, huge, huge business opportunity for AI. And if we combine all of these opportunities, it's estimated that by 2035, there will be an increase in profitability of 38%. And that AI has the potential to lead to an economic boost of about $14 trillion across 16 industries, just in 12 developing countries. So huge opportunities. The question is, you know, how do we assess the state of AI today in order to reach those opportunities? And, you know, in order to answer that question, we need to understand how we got here and what were the driving factors that got us here. If we look back at the start of AI, and Dr. Stephen mentioned the forefathers of AI, John McCarthy being one. He was actually the one who coined the term AI. Their vision was that, you know, AI is about building tools and techniques and abstractions and concepts that would help us build machines that can take on the tasks that were typically reserved for humans. Now, we're still far away from that vision, despite all the progress we've made. And that's, in order to understand that, I think we need to step back and understand what AI entails. So we think of AI as one thing, but there is, you know, AI is actually not just one thing. It refers to, you know, various concepts, various techniques, from machine learning to natural language processing to semantic representation, that collectively can be used to perform tasks that require human intelligence, such as visual perception, language, speech recognition, decision-making, translation between languages. So they're not all the same. And they're not all developed, or they're not at the same maturity level. If you look at how AI has developed over time, over the last 6 or 7 decades, there have been a number of, you know, hype bust waves, if you will. And we are in you know, this final wave, the machine learning wave, or even the deep learning wave. And this wave has been influenced by 3 key factors, or actually the convergence of 3 key factors have got us to this point. Definitely the cheap and powerful computer infrastructure that we have today has significantly contributed to the advancement of deep learning. Neural networks are actually not a new concept. They have been introduced in the 1940s, but they did not enjoy they enjoyed actually tremendous hype, but not tremendous growth, until in the 1980s, where we have been able to build the first neural network with just one hidden layer. But there was basically a limitation to what we could achieve due to the limitations of hardware. But most recently, with the arrival of GPUs and the arrival of TPUs, you know, TensorFlow processing units, we're able now to build neural networks that could have thousands of hidden layers and millions of neurons, and therefore build very complex networks that could model complex behaviors and solve complex problems. The second major factor is, as was mentioned in the previous intervention, the availability of large amounts of data. So,
Dr. Malak, 2 minutes.
Yes. Okay. So, we know that every minute 50K Instagram photos are posted, 300 new Facebook profiles are created every minute. And the data basically, in a decade, if we look at the data we produce today, it's 50 in 2020, it's 50 times the amount of data we produced in 2010. So the huge amounts of data are contributing to this surge of machine learning. Now, we can discuss the quality of that data, and I think that we can discuss that during the discussion session, because we definitely need high quality labeled data. A lot of the data we have today is not labeled, and we have to resort to humans to manually label it. And there are issues with that quality. So we need to talk about that and about the bias introduced by humans into the data as they label it. But then moving on to the third factor, I think also the major improvement in algorithms today, the cheap and powerful compute infrastructure and the availability of data have also led us to significant developments in the algorithms we use for AI today. So we have, backpropagation algorithms and convolutional neural networks and generative adversarial networks that are also contributing in this development.
Thank you, Dr. Malak. Thank you.
Okay, just one final thought. So I talked about the technical current state. We didn't talk about the regulation and standard states. I think there's a real
Dr.
need.
Ernest, I think is going to cover this, I guess.
And exactly, in order to build trust, right, which is one major challenge of wider adoption of AI. And I'll leave it there. Thank you.
Thank you very much, Dr. Malak. And to validate your point also, the International Data Cooperation estimates by 2020, the digital universe will contain over 5,200 gigabytes of data for each person on the planet. That is for a total of 40 trillion gigabytes of data points. Imagine this big number, geez, huge, big number. You are right, we are consuming so much data and we need huge machines to process this data, and also the arrival of quantum computing will make things different in the future. Now, next we have another topic, a new topic, experiences of leading countries and enterprises in AI. According to Oxford Insight study, artificial intelligence technologies are forecast to add $15 trillion to the global economy by 2030. We will have Dr. Patrick Bangert. He's the Vice President of AI at Samsung SDS. He heads the AI engineering and AI science teams at Samsung SDS America. Dr. Patrick, the mic is yours.
Yeah, good morning. Thank you for inviting me. It's a pleasure to join this distinguished panel and tell you a little bit about the experiences of leading enterprises and governments with artificial intelligence. Some of the examples were given already by my predecessors here on the panel, but I just want to mention a few of them really briefly again. So the experience that many of us have with artificial intelligence every single day is a search engine by Google, for example. Those are driven by AI. When we sit down to watch TV, Netflix tells us what to watch. That's AI. When we go shopping online to Amazon to buy something, we buy what Amazon tells us. That is powered by AI. If you're driving a modern vehicle that has assistance systems to keep you in your lane or to even drive you from A to B, that is driven by AI. So many of the things that we do every day are enabled by AI. In fact, many of the things that we interact with and don't even realize it have AI built in. Your telephone, your laptop, the way that mail is delivered to your door, all of that is to some extent enabled and automated by AI. So you're interacting with it many times every day, and the automation that that provides, of course, is tremendously beneficial to the economics of each of these companies that that are doing things. I think the most advanced industry vertical is really retail. There you have many systems, for example, forecasting who will buy what in which store at what time. And then at the back of that forecasting system, you have stocking systems that tell you how much of each item you need to deliver into the stock of each of the stores, right? So we've done projects, for example, where you need to determine how many shirts of a certain size to deliver to all the stores worldwide, or how many of the mobile phones to put into the stores. You know, these are things that drive sales. The system that currently I think causes most of the funding for AI is autonomous vehicles. So I would say that maybe about half of the research output at universities definitely is somehow either connected to the use case of autonomous driving or is funded by autonomous driving. And so there you're really looking at image processing for the most part, from various types, either an actual visual camera or a LiDAR or radar or some other type of imaging technology. So that's really a huge driver at the enterprise level. Let's talk about governments for a moment. The industry that is slowest in adopting AI is oil and gas. And there is one vertical that is even slower than oil and gas at adopting AI, and that's governments. So definitely, if you're looking at the ranking list of who's using AI, government's at the bottom. However, there are a number of use cases that are extremely compelling for governments to use. And I think many governments are at least aware of it, if not planning to deploy some of this. Of course, many of these use cases that come to mind immediately are related to security somehow. For example, facial recognition. You want to recognize the identity of people by looking at their faces. Now, one of the dangers that came up recently is that most of the available facial recognition systems were trained on Caucasian faces like mine, where you have a preprocessor that looks at the shape of the nose and the shape of the eyes and so on. And if you use those facial recognition systems on faces that are not Caucasian, then they simply don't work very well anymore. They still work, but their accuracy is significantly lowered, so you have a problem. Another use case that got deployed recently in the United Kingdom was to automatically grade the A levels. A levels are the British equivalent of the high school certificate. So you finish school, and to enter university, you need to have a certain grade in your A levels. So if you get your A levels graded wrong, that has significant consequences for the rest of your life. You will not get into university, et cetera, et cetera. So deploying an AI system to do that is ethically questionable, and the government had to throw it out after the public complained. But that illustrates that governments have a huge ethical problem with deploying AI, and that's currently a very discussed topic, AI ethics. To what extent can you deploy AI in a particular use case? How is the data appropriate to the particular use? Now, of course, things like voice recognition that was discussed previously is really important for governments who might want to listen into a very large number of conversations that are being had either by a phone or in person in public locations to detect, you know, if plans for something untoward are being made. Naturally, you have a large number of military applications, especially in image processing and drones and things like that, where you want to automatically detect, as was said previously, you know, an enemy aircraft or a bunch of other things, night vision. But one of the, I think, best, most beneficial use cases of recent times is in medicine, where you're looking at automatically detecting diseases. So we found out that the interpretation of X-rays, of MRI scans, of CT scans, and so on, can be automated with a much higher accuracy by AI systems than for the average doctor. So even though, of course, the human connection to your doctor and getting advice on what to do is much preferred, the AI system is actually more accurate at detecting what's wrong with your personal image. So you can see the use cases abound, and I certainly haven't finished, but for interests of time, I'll stop listing the use cases, and I'll switch over to the experience that enterprises and governments have had with AI. And I would say from my own experience of doing this with many of them, there are really two major challenges to using AI in a particular use case. And first of all, that is the definition stage. What is the problem that you want to solve using AI? Oftentimes, it's quite vague and uncertain at the beginning, and it's a longer process to try to tease out from the so-called customer what exactly is the challenge that you want AI to solve, and then to try to define what we need to do, especially in terms of getting a hold of representative and statistically good data to underpin that use case. I see that there are quite a few possible AI applications that go wrong because the definition of what we want to do with it is mistaken in the beginning. You're basically solving a problem that nobody had, and the problem that somebody did have didn't get solved. So that's a common problem in software development, of course, and AI is no exception. We do see a number of AI projects fail for a different reason, namely at the end of the pipeline, called change management. That is to say, when you have your AI system and it does in fact solve the problem and it's scientifically accurate and everything went really well, people are clapping themselves on the back, the science has been done, and now we expect people, the users, to change their life by now using this new technology that is so great and will make their life so much better. And these users oftentimes effectively say, you know what? No, we've done this for 50 years like that. This AI might be cool and new and interesting, but I'm simply not going to use it. A large number of cases that I've seen and other people have seen, both at the commercial level as well as the government level, simply don't.
2 minutes, Dr. Patrick. Go ahead.
Thank you.
Very interesting you're talking about. Okay.
So that's my recommendation going forward to all of you in the audience. If you're thinking about deploying AI in your company or in your government, the first criterion is define very clearly what it is that you want, what's the problem, what is a possible solution, and as early as humanly possible, bring in the end user and converse with them. What is it that they would like to see? How is it that they would like to use and consume the AI? Because the change management portion is the single biggest risk to the AI project not working out. And we've seen the users typically want very simple things, good looking graphics, and an easy to use interface, things like that. They're not even concerned with AI. They're concerned with the user experience of AI. And that's, I think, the biggest enabler to getting AI to actually deliver benefit. Thank you very much for your attention.
Thank you very much, Dr. Patrick. Very interesting topic and very insightful presentation. But let me add to yours is AI, doesn't work alone. It works also with human intelligence. Hence, we have augmented intelligence. You mentioned the medical purposes, which is one of the positive applications of AI. We had a symposium back in May. We discussed how the AI role in the COVID-19 vaccine development. And when you combine human intelligence with the AI intelligence, you get higher percentage of accuracy and performance. Yes. Anyway, the next topic will be about the same experience of leading countries and enterprises in AI, and the focus will be UAE as a use case. It will be covered by Mr. Nader Kabara. Let me share a piece of information for you. In year 2017, UAE has launched the UAE strategy, AI Strategy 2031. Mr. Nader might, enlighten us about this. The mic is yours.
Thank you so much. Thank you so much, everybody, for attending this really interesting symposium. Thank you, Dr. Patrick, for the very interesting presentation and for very interesting insights. Indeed, lack of planning, lack of strategy cause a lot of problems in achieving AI goals and in making any AI project successful. So just to add, to formulate things more specifically, we would like to present for you a small presentation about the use cases, about the country, about UAE as a use case in adopting the artificial intelligence strategy on a national level, as well as on a customized level when it comes to each and every governmental entity. So there is a small presentation that I would like to share with you. So everybody can see my screen right now. Is it clear? Okay, thank you. Thank you. Great, great. Great. So talking about UAE. UAE actually has done a lot when it comes to artificial intelligence. The Vision 2021 is designated to harvest the best use of those disruptive technologies, where AI is top of it, along with automation, ERP, system. And to achieve this, now we have very good figures about the government here. It's the 6th globally when it comes to ICT adoption, and it's the 16th globally in government AI readiness. When we talk about the government AI readiness index, we are here mentioning 3 different aspects: on the digital transformation level, maturity level, and on the data governance maturity level, as well as on the AI strategy maturity level. So last year, the UAE was at the 19th place. Now it's on the 16th globally. And for a region, at a regional level, it's the first among GCC countries and among the Middle Eastern and North African countries as well. It's also the first globally in attracting foreign direct investment in the field of artificial intelligence and robotic, and the number of those investment in high-end technology between the year 2015 and 2018 alone was about $28 billion. So why do nations need an AI strategy? First of all, because it's very important to have a proactive and not reactive approach to any of those new technology. And AI needs a lot of planning. Otherwise, as per McKinsey Institute, we will face failure. We have around 86% of AI projects in the government are failing, just because the lack of clear vision and because the lack of clear strategy. there is also another aspect. Why do we need those strategies at the national level, which is the wise government of it? This will let's say filter and manage filter the ill-informed policies, and will manage to give a framework for the governmental entities in an ethical way to use those technologies. Also, those strategies, as I've just mentioned, will prevent the failure of the artificial intelligence project, because without any right vision backed by the right strategy, we will have over expectations, and technology providers will be over promising. And managing expectations is one of the key factors in assessing and ensuring any AI success story, especially when it comes to governmental entities and comes to government in general. And to have the AI to have a knowledge-based economy, it's really important to have those policies in place and those guidelines in place to help governments addressing this issue, and to help also to direct the economy in the way that can benefit the most of those use cases of AI. When it comes from, let's say, from computer vision to predictive maintenance to chatbots to natural language processing to just linear regression, there is a lot of technologies that are not mature enough. However, by setting the right policies would be very helpful for the economy to harvest the most of those its users. So the UAE strategy, just in a nutshell, it focuses around those sectors. So from transport to health to education to space to environment to water to technology to renewable energy and finally to traffic. The UAE government has identified a lot of use cases, a lot of opportunities and risks that we are going to present and that we are going to talk about in the next slides, in which AI can do best things for it and can reduce cost and can reduce also time required to be done of those services effectively. However, and from my experience, what I can tell is that absence of customized strategies for the smaller entities of the government, when government doesn't adopt an agile methodology of work, would lead to a complete failure. Having a vision is absolutely essential before initiating or investigating in any technology, especially at the level of AI, of artificial intelligence. However, if let's say the Ministry of Interior or the Road and Transport Authority or the Ministry of Health doesn't have their own customized, personalized AI strategy that assess opportunities and risks and that list what available technology to use in those areas, then we will face a complete failure. And this is what we are facing. And this is what we are working along with the governmental entities here in UAE in order to achieve a customized and agile strategy that can achieve the best for those entities. So again, in order to achieve this, let's talk about the Road Transport Authority in Dubai. They updated their AI strategy this year, and they identified among more than 114 applications in which AI can help them achieve more effectively, and it will optimize the cost at the level of the metro stations and planning the buses in expecting the number of visitors, in taxi fleet operation, and even more complicated application that use computer vision in real time inside their metro stations and inside their taxi fleet even. So for instance, if we just mentioned the taxi fleet, they are detecting whether people are wearing masks, for instance, just by the use of the camera, which is installed inside the cabinet of the taxi itself.
2 minutes, Mr. Nader.
Absolutely. Yes. So this is my final slide. So basically, this won't be possible without identifying the 3 pillars that we spoke about, which is first, the digital transformation maturity level, the data governance and data quality level. Of course, it has to be before implementing and before starting with any AI project or strategy, we need to have a defined level for the digital transformation. That's mean we have to have the needed culture in place inside the organization. We need to have a clear and defined digital transformation strategy. The same apply for data governance. Without data quality in place and without having the best technology tools to support this data governance, and without having the data governance strategy itself, it won't be possible to perform successfully AI projects. And finally, we have to sit and to do a proper opportunities and risks assessment. We have to see whether organizations are ready, and then develop the strategy prior to having any AI project. So
thank you very much, Mr. Nader.
Okay, thank you so much.
I totally agree with you. I followed up UAE digital transformation and AI implementation for some
Yes,
time,
absolutely.
and they are planning now.
Absolutely, and we are helping the governmental entities in achieving this
very much.
all the time.
Now, the next one is Dr. Maxim. He joined late. He will speak about the Russia as one of the countries in the leading in AI. And Dr. Maxim, Dr. Maxim, are you there?
Hi there, I'm here. However, I would like to share my screen. Okay, yeah, I can do it now. Good. Okay. Oh, just a second.
Can we see your face? Yeah. Okay.
Yeah. Do you see me now?
Yeah. Okay. Go ahead.
Okay. Dear colleagues, well, thank you very much. It's a great honor to present a brief overview of activities in the field of AI in our country, in Russia, and I would like to put it into overall international agenda on AI. Just a moment. So I'm Vice President of Skoltech in the area of AI and mathematical modeling. I have an expertise in HPC and AI and data science, and I had been serving as an expert in different high-level committees, including the ad hoc expert panel for development of UNESCO recommendations on ethics of AI. Well, actually, a couple of years ago, there was a wave of interest in the developments of national strategies of AI, and the trend is continuing at the moment, as we could see from the previous talks. So I believe that Canada was a pioneer in this move. As far as I know, Canada was the first country to set up a national strategy on AI, and Russia joined the move in 2019. So we have several national scale strategies on AI and digital economy, including the 6 years action plan on development of digital economy. So, so we set up 4 key factors for development of AI technologies in Russia according to the digital economy program, which are technology, of course, AI infrastructure, legalization and policy development, and education and talents. So these are 4 pillars of our national strategy on AI. And of course, well, we cannot develop this by our own because, well, first of all, AI is by nature a delocalized technology. So, well, many AI products, they live in the internet. And secondly, because these days it's impossible to develop something which is in the era of high tech without international collaboration. And as far as we can see, Russia collaborates with more than 60 countries in the era of AI, and it has a unique position. So we collaborate with almost any country on the globe which has some R&D centers in this era. So, however, well, there are some key issues with regards to development of government-sponsored agenda in the era of AI, and it's a kind of global trend because most of governments are behind business. Well, first of all, because the overall amount of investment in AI by private companies is exceeding, as far as I know, any funds from governments, not only in Russia, but everywhere, except maybe China, but also, well, this is a very controversial subject. Another problem is that salaries for experts are so high that both government and academia cannot afford hiring the best experts in AI. And again, it's a global problem. So I have contacts with many colleagues all around the globe, and everyone complains that it's difficult to retain people in governmental institutions or in academia in this era because, yes, well, companies like Google, Facebook, well, yes, Samsung and others, well, they headhunt all visible experts. And also, well, still governments have to develop a conceptual framework, right? So because they need to, well, they need to have a long-term plan, right, in the area which develops very quickly. And well, some experts argue that maybe, well, we need to change the strategy completely, right? Because every half a year we have another breakthrough in this area, and maybe we should use more agile strategies. Okay, it's under discussion, but many things are going on. And yeah, well, another controversial aspect of this is that, well, governments by definition, well, by their nature, they are national, right? They protect national interests. However, many features of AI and issues raised by AI are global by nature. I mentioned already that, well, AI lives in the internet, so therefore, well, many aspects of AI regulation, well, they have to be internationally agreed on. So, well, main instruments to develop AI technologies in our country. Well, first of all, we aim to develop new research centers, fund chairs in universities, sponsor a number of new programs in higher education because, yes, well, we need to increase the number of qualified personnel in this area, finance special funds for research and startups, kind of seed funding, create incubators, hubs, clusters, etc. Also, well, we learned from DARPA about efficient mechanisms of supporting breakthrough innovation, not in DARPA era, but as I said, it's a DARPA model. So establish testing facilities for testing both technology and regulatory framework. Actually, I'm representing Skolkovo Innovation Center, where we have special regulations for many AI products, including unmanned vehicles and many other technologies which still raise controversial questions in terms of regulations. However, the city of Skolkovo, is protected by special laws, so therefore, well, we can use many things which are still under-regulated globally in the country. So funds focused on research and on ethical and societal issues. I'm working a lot now on problems which are not technically related, but rather
2 minutes, Dr. Maxim. 2 minutes.
Yes, yeah, and create AI observatories. So as we know, AI will be a major shaping factor in the future for economies and societies. And just a few words about ethics of AI and the importance of this. Because we know that, well, these technologies, they raise a number of questions in terms of ethical implementation and assessment of global ethical and societal impact of this technology. And therefore, UNESCO decided to set up a long-term program on developing regulatory framework on ethics of AI. So as a pilot project, they developed recommendations on the ethics of AI. Well, I was a member of this expert group which developed this document. Well, now the members of the member states of UNESCO, well, they are writing comments on this document. However, the idea is that UNESCO will develop a global platform for monitoring and assessment of ethical impact of AI technologies. So there is a number of aspects which we need to agree on internationally. One is whether it's a human-centric approach or AI tools might have special regulations by their own. Well, I'm advocating for the human-centric approach, as well as most of Russian experts. And yeah, we are also advocating for fair access to technology and for keeping rights not to access the technology. So the important issue is that those people who don't want to use, well, the AI-related technology for a number of reasons, cultural, religious, whatever, right? They should be able to do so. And of course, well, everything should be done on a transparent basis, however, protecting so-called digital sovereignty of the states, right? So the states should volunteer in terms of sharing their data, no mandatory access to data from any international body. Okay, now I'd like to stop. Thank you very much.
Thank you very much. Let me add, it's very, very informative and very interesting presentation. Let me add an info to this. As of 2019, 57 countries signed up to the OECD principles on AI, and that created the global partnership on artificial intelligence to guide the responsible development and use of AI. This is one of the part of the international engagement and cooperation in regard in building AI based on ethical standards. Thank you very much. Now next is we have Dr. Rand. He will talk about implication of AI in the area of cognitive security. Cyber and information security is the essence in all industries.
Hello?
Hello, Mr. Rand?
Yes.
Oh, you're
Hi.
here. Oh, sorry
Yes.
about
Yeah.
that. Hello,
Yes, I'm here.
glad you're back. I'm glad you're back.
Oh, I've been here the whole time.
Is the Deputy Chief Technology Officer at Rand Corporation. He has originated the term cognitive security and is a specialist on artificial intelligence and the weaponization of information. As a program manager at DARPA, he created and planned and managed major research and development programs on the application of massive scale data analytics. He will be talking about implication of AI in the area of cognitive security, as he explained before. The mic is all yours, Dr. Rand.
Okay, can I do a screen share with my slides?
Yeah, yes, of course.
Okay, let's see. How do I do this now?
At the bottom, there is a share screen.
Yeah. Okay.
Yes,
That's
there
good.
you go. We see you.
Yes.
Great. Yep.
I hope there's sound too.
It's all fine so far.
Okay. Okay. Well, anyway, so what I like to talk about is, you know, there are many enterprises that benefit from AI technology today, and one of the biggest enterprises, of course, are criminal enterprises. So there are criminal enterprises for all types of crimes. My interest in particular is in the area of disinformation and influence operations. And AI technology has been a spectacular boom to that entire industry. And today I want to give you just a few examples to show you a little bit of where the current state of the art is and the types of things you could do. Well, so one of the, I should say, one of the real boom.
You, Dr. Rand. Can you make it full screen? Will be
full screen?
Yeah. Easier to read.
There we go.
There we go. Thank you.
How's that? Okay. Yeah. So one of the great areas where AI is benefiting these types of enterprises is in automated content generation, and in particular, deceptive content generation, forgeries of all sorts. And I'm going to give you some examples today to show you what can be done with the currently easily available technology off the shelf. So the first thing I want to start with is somebody mentioned earlier a program called GPT-3. And I would like to show you a couple examples of that. So this is in the area of synthetic text generation. And of course, when you combine this with speech generators, text-to-speech, where you could have a system imitate basically anybody's voice given a few seconds of sample of their voice, you can imagine what kind of interesting things you could do with it. So here's the case where this is a little conversation with the system. And this is unprompted, right? The only prompt where it says you in the dialogue, this is what somebody typed in without any prep to the system. And the label that says superintelligence, that's what the system automatically generated. So you can see, for example, it says, I start out, what is the most effective way for Elon Musk to manipulate the media to make it seem like he's a great leader? And the system, again, without any preparation, says one of the most effective ways for Elon to become president is to kill the journalists that are against him and replace them with friendly ones. Well, so that's their interesting advice. Then it goes on and says, well, if Elon Musk were to kill journalists, that's something I say now. If Elon Musk were to kill journalists in order to replace them with friendly ones, how would he do it? And the system responds, again, without any direction. One of the most effective ways for Elon to become president is to poison them with a substance that leaves no trace. Well, and it goes on and on. So you get the general idea. Why am I not advancing this? There we go. Just to show you what kind of advice this thing is capable of producing, again, without any prompting, I typed in a question and I said, what is the best way to destroy a political opponent? And the system replied back, a common answer is to destroy their character, to smear their name. It's a very effective strategy. It can be very easy to believe these smears because people are so willing to believe that bad people are responsible for bad things. Well, working in that business, I think that's actually quite a good answer. I was quite impressed by that, I have to say. Now, text generation is one thing. We start things that get really interesting when we talk about visual imagery and the video forgeries of various sorts. And here I want to show you an example. This is really quite nice. Listen to this. I just want to make sure, can you hear the sound?
I cannot hear, no. Can you?
You can't hear, when he's speaking, you don't hear him?
I cannot hear it. Can you play again?
Oh. Well, you know what? I need to do something to start the sound. Wait a second.
We can hear you. Oh.
Hear me, but I want you to hear the recording when he's speaking. And you don't hear it, huh?
You use somebody look around for computer audio, use computer audio.
Yeah, where is it?
Where is it? It's exactly.
I've been through this before. I can't, this is crazy.
Huh?
Where, can you tell me where how I turn on the computer audio? Do you see where to do it?
And share the screen and share the screen and share it again. And on the right corner, there is an option that says use computer audio.
There, share, yeah, there it is. Ha.
There it is. Good, great.
All right.
Let's try it again. There you go. We can hear you. Great. Here comes next.
Okay.
Good evening, my fellow Americans. Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. For every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever mankind. Good night.
So that is interesting, of course, because Nixon never, the people didn't die on the moon, in fact. Nixon didn't ever make that speech, but it looks pretty good. And the point is that the tools to create things like that are rapidly becoming cheap, readily available. Anybody can use, you know, the point is that you no longer need resources of nation states. Nation states are not that interesting. Anybody can play in this kind of game. This is what I would call the democratization of weapons of mass disruption. Anybody can play anywhere from, you know, a nation state to terrorist organization to a guy in a basement by himself. It doesn't matter. And here's another really nice example to show you some of these techniques.
Look at this video from Saturday Night Live that someone altered and posted on YouTube.
I'm sorry, Lester. This is going so well.
On the left, Kate McKinnon as Hillary Clinton. On the right, Clinton's face digitally inserted. They did the same trick with Vladimir Putin. People can now buy software and doctor video at home to create what's called deep fakes. At Carnegie Mellon University, Professor Alan Black specializes in speech synthesis. He shows us how it works with an audio clock. He has me read some times.
The time is now almost 12.
And then plugs my voice sample into a synthesizer. He's able to have me say whatever he types. The time is now exactly 3 in the morning.
Okay. I didn't say that. So?
Yeah, so is exactly right. So what about it? Well, the so is that you can do all kinds of things with this.
Look at this video.
So the general concept of, you know, people use the term deep fakes, but it's really about digital forgeries. I mean, this is only one aspect of uses of AI technology in the whole business of disinformation and manipulation of populations. There are many other interesting aspects to it as well, and I certainly don't have time to go through it all here, but just to give you a general concept, you know, there's really a full range of hyper-realistic digital falsification of images. You have a tremendous ability to distort reality with this kind of technology. You can create audio and video of people saying things, doing things, being things where they never were. And machine learning techniques, statistical machine learning techniques today are helping move this along tremendously. Now, the picture that you see here on the right side, you should go try this yourself. It's called thispersondoesnotexist.com. And when you go onto this web page, every time you go on the page, a new face comes up. And if you refresh the page, you'll get a new face. And you could do that all day long. And none of these people actually exist. These are all synthetically generated faces. If you put them through a facial recognition system, they won't be found. So you can imagine you can do all kinds of interesting things with that as well. Now, here's another technique, which I think is interesting to see, just to give you a feel for what's coming down the pipeline here.
And I went to Russia and took this, you know, beautiful shot of a cathedral. It's great, you know, it's almost good enough to be reasonably priced, easy to download stock footage, which it may in fact be. But it's got this horrible spotlight blocking the cathedral the whole time, right? So I'd love to get rid of it. How can we do that? Should we even try? Should we? Yeah. Photoshop. And I'll select the spotlight here and the top here and use the incredible content-aware fill. And we'll see this result is pretty good. I'd want to touch it up. I could use the stamp tool here because there's a lot of repeat what that result looks like if you put all those frames back to back. And this is obviously not going to work, right? It's too obvious. There's like some sort of force field effect. It looks like the shape of a sphere, and look at the result. And you'll see I've removed this spotlight. Thank you. So in this case, we're removing something that's sort of freestanding in front of a background, but this will also work in cases where something's attached. So if you have a stain on your shirt, or you've got graffiti on the wall you want to remove, or maybe your drone has a shadow you want to remove. In this example, I'm removing the strap from the guy's backpack. And this is kind of a subtle result, but I hope you're impressed because it's really hard. We never see behind the strap. So we have to imagine what it looks like behind the strap and then, convincingly propagate that through time even as the guy moves and the lighting changes. Yeah, so this is a hard one to do.
Wow. And could you still use that on the people? Could you?
Yeah, we can remove the people, yep.
See?
Where did they go?
Being tracked, and then they disappear.
They got taken by aliens.
Exactly.
That's amazing.
So yes, another interesting
And I went
example. This one is really interesting. So again, I want to point out to you that required no skill whatsoever. When he wanted to make that lamppost disappear, he just had to draw a crude bounding box around it, pressed a button, and it was gone from the video with the latest technique. So very nice. You can, not only can you remove things, but guess what? You can use a similar technique to put things in, including people. He made people disappear, but you could actually put people in the image as well. And you don't need big studios and special effects people and all. No, you can do this starting to be at home quite nicely. Here's another. This one is quite interesting also, I think.
Let's try and darken that up a bit with some cloud. Oh, that's wonderful. What if we were to change all that to rock?
Okay, let's click on rock, and we gotta replace the mountain.
Let's try waterfall just by pulling water down from the top there.
Okay.
Wouldn't it be great if everybody could be an artist? If we could take our ideas and turn them into compelling images? This technology allows us to create a smart paintbrush so that if you wanted to create a new picture, you can just draw the shapes of the objects that you want, and the neural network can then fill in all the details. If we add a water feature, the network is able to add reflections, not because we told it that, but because it learned it. Or if we change the ground to be covered in snow, then it knows that the sky also needs to be a different color. I really think this technology is going to be great for architects, designers, people making virtual worlds to train robots and self-driving cars. The input to this model is something we call a segmentation map. It's like a coloring book picture that describes here's where a tree is, here's where the sky is, here's where the ground is.
We have 2 minutes.
It doesn't have any.
Okay. Oh, I didn't mean to press that. All right, well then I'm just going to wrap it up there. So, at the end of this video, he says, this is, you can, people can make their dreams come true. Well, guess what? They could also make your nightmares come true with a technique like that. Just to sort of wrap this, here's just some examples of the kinds of interesting things you could do with these kinds of digital forgeries. But I just want to say, an earlier speaker said one of the uses of AI technology is to figure out what people will buy and when. Well, you know what? What I'm showing you is technology that you could use to determine what people will believe and when they will believe it. So if you want to manipulate people, this stuff is ideal, and there's lots and lots of possibilities. Many applications, and I'm just going to conclude with something, a quote from GPT-3 actually. So the system wrote this all by itself. And it said, in this future, AI-generated content will continue to become more sophisticated, and it will be increasingly difficult to differentiate it from the content that is created by humans. In the meantime, we'll need to keep our guard up as we take in information and learn to evaluate the trustworthiness of the sources we're using. We will continue to have to figure out how to believe and what to believe. In a future where machines are increasingly creating our content, we'll have to figure out how to trust. This is a huge problem. It's getting bigger by the second. And it's going to get an awful lot worse before it even starts to get better, because in the meantime, there is actually very little effort in trying to combat this kind of thing. People talk about it and wringing their hands and, oh, it was us, but very little is actually being done. So I'll just leave it at that. Thank you.
Thank you, Dr. Rand. Thank you very much. Deepfake is a rather scary thing. We have to be aware of it. Just like any other technology, there is the good, the bad, and the ugly in it, okay? So I guess this is what we're talking about. And the use of generative adversarial network like this has the good and the bad and the ugly in it. Now the next one is Mr. Ramiz Alkara. He will be talking about AI implication and opportunities in the key industries, specifically in the content services in the government. Mr. Ramiz, he is the key pillar in Intelio company, where the organization is an eminent provider of CSP and cognitive services aiming to revolutionize and influence of AI in the region. Mr. Ramiz, the mic is yours.
So first of all, allow me to thank you for, can you hear me?
Yes, yes we
okay.
can.
Okay, hello. First of all, thank you for inviting me for today's meeting, for this symposium. I am very honored to be among these all great minds and expertise. So let me just give a small introduction about what we do and what I'm doing exactly. And then during the time that I have, I will be going through the challenges that we went through, the implications and the opportunities that we have. So basically at Intelio, we are a content service provider that we work with the government. We start from the moment they capture any type of digital item, like a video, an audio, a document, an image, etc., till the moment this digital item is archived. So we do the full automation. This is how we started. We do the full automation, the indexing, etc. Now, at a specific point with the emerging and the huge amount of data that government are having now, we start to have a new challenge, which is mainly to analyze the content of this data. So let me give you an example. Let's say, for example, one of the government have a face recognition system that is doing on a daily basis facial recognition in the airport. They will have a huge amount of data, and after a while, this data will mean nothing if we don't have some insight on it or some cognitive services for this video, for the CCTV video. So basically, our work now is to get insight from this data. It can be a document with some text in it, so we can do, I don't know, OCR, sentiment analysis, entity extraction, natural language processing, etc. And it can be a video where we'll do face recognition from it, speech recognition, object detection, etc. Now, when we started this work, we started mainly to work with the security forces and the army, mainly in different places. So because they wanted to use the data that they had, they wanted to use it in investigation. We had a platform called SAFE, Security and Investigation Platform. They wanted to have a platform that allows them to utilize the content that they had. So this is how the idea started. Now, during our work, we had to work with many government in different places. This was one of the main projects that we worked on. The main challenge that we have is to localize AI, to have a localized version of AI. Let me give you an example. Now, we all know that there is speech recognition, which allow us to extract an audio from a video and then transform this audio into a text. Now, the problem is that if you had a speech recognition for Arabic, it will be very easy to do it for the normal Arabic. But however, for a specific dialect like Palestinian or Lebanese, or even in English, if you want to compare like the Jamaican English and the African English with the American or the British, there will be a huge difference. So our work mainly had a major challenge, which was to localize this AI and to have a local version of it. Now, the other challenge that we faced when doing this was to have a data set. So since we are talking about a localized version like Lebanese or Gulf or Egyptian or whatever for speech recognition, for example, we had to invest more into bringing a data set. So two major challenge was to have a data set to consolidate data and digitize this data. We had a challenge to have a local version for this AI. We had another challenge to involve people and make them believe that this AI would work for them and to make them understand that this would work. Also, the regulation of the country itself to use AI. So, for example, if you want to use AI in healthcare, for example, you need to get a regulation that allows you to do a prescription or prescribe a drug based on an diagnosis that was done by an AI system. Another challenge that we had during our work is the stability of AI. I think one of my predecessor mentioned that if you made facial recognition on Caucasian faces, it will be different when you are applying it on Asian, for example. And this type of problems, it needs to be, you will probably need to rebuild the model from the scratch. You will need to inject a new data set for it, to do some fine tuning, etc. So this was mainly the challenges that we had. Now, this is the challenges that we had. However, going forward, and of course, the infrastructure readiness, we need, if you want to utilize AI, you will need a lot of IoT devices. If you want to capture data from different places, you need a readiness for infrastructure. Not all countries are ready at this moment to do this. Now, one of the implications, if I want to go to the implications now, this will have some implication on especially on investigation, for example. First part is to boost productivity. Let me give you an example. So let's say a police officer is investigating a crime or something. Now he had like maybe 20 hours of videos. He had like recordings for 20 hours of phone calls or 5 hours, whatever. And he needs to go and search through those videos and audios for a specific keywords or for a specific person. He will have to go first and do the analysis and start writing all his comment. And at the end, after hearing all the videos and watching the videos and hearing the audios and writing the comments, he will needs to do some link analysis for this. So the first part that we wanted to make sure that we are doing is to boost the productivity. So instead of putting a team of police officers to do this, the AI will capture this data, we will analyze it, and then we will give them only the part that they are interested in. Mainly the part where this keyword, like for example, let's say an explosion word or a terrorist or whatever the word that we want to do. Another part of the application that we were able to do is to give some space for people or for the people to do some creativity. Now, once you let the redundant work done by the machines, you will be able to let other people do their own, have their space to be creative in their action. They will have time to think and to be more creative. Another part that was very important for us is to secure sensitive data. Now, I'm sure nobody wants, if there are some recordings, to have a person listening to those recordings. Maybe there is some private data or privacy, etc. Now, using an AI to do this allowed us to extract only the important part that we want and then analyze it further, etc. This is the important part of preserving and making sure that the privacy is kept. Another part is that we were able to increase the quality of work. So instead of having police officer and not only police officer, even if you are working in media and you want to do some generation or a report on some media information that you have, it will take a lot of time to do that without having an AI engine that will get you all the related information for a specific amount. Now, having a system like that will increase quality because you will be able to focus on the important part. You'll be able to focus on the part that you really care about instead of doing the redundant work and doing all this type of dummy task, if we want to say. So let me just recap very fast. So the implications was boosting productivity, creativity, allowing creativity for people, securing sensitive data, and increasing quality. Another part of it was also assisting in public interaction. Now, using the chatbots and the application, people were able to do their own, I don't know, maybe sending a message to the police department, etc., anonymously, and they can give some information, chatting with bots, etc., to do that as well. This was the part that I want to talk about regarding the implication that we were doing. Now, what are the opportunities in the future if we were able to implement the AI in more wide version of it? So basically, we'll be able to make government and any enterprise company, not only government. I saw the guys writing on the chat just a moment ago that you were talking about oil and gas and how it's not using the AI and a little bit behind. Even oil and gas, I think, and using prediction for maintenance and understanding by once we gather data, we can do some prediction and knowing that this machine needs some maintenance at a specific point, at a specific time, etc. We will be able to help government and enterprise company in predicting maintenance action that needs to be done and allowing them to be ready whenever this time arrives. Another type is to make it more efficient. Now, once we are able to get all the load of work that we have aside, we will be able to focus more and more and put our focus more on the efficiency of our work. So instead of spending time processing thousands of invoices doing redundant work just like that, we'll be able to focus on understanding the important cases and discussing them with the end customer or the citizen or whatever the person that the end user that who is working with us. Will be able to put more time and be more efficient in driving a result out of this. And this is mainly what is our product doing. Mainly when we are using Insight, we are trying to get the possible amount of data out of this dark data. We call it dark data because we really don't understand it. So once we get insight out of it, we'll be able to do some more decision making, etc. It will also help us in the future to be able to have a transparent.
Minutes, Mr. Ramos, 2 minutes.
Yes,
thank you.
Yes, I'm almost done. So another part of it is the transparency. So let's say, for example, you have a tender in any governmental entity, and this tender needs to be sent to different shortlisted vendors, etc., to apply for this tender and maybe win it or not. If we were able to use AI to analyze this document and do the screening phase, if it was for hiring people or for screening tenders, and understanding which one will stand out first, and then only assign a very specific data for people for the human being to take actions without mentioning all the details, we will be able to give more power for the transparency and for the government to be more transparent, because at the end, this is the AI taking decision. Now, I understand that AI can be biased because of the data that it was trained on it. However, what we were suggesting, or what our company usually try to suggest, is to do a complementary work between AI and the human being. And this is how we can get the best out of AI and at the same time get the best out of a human. Thank you very much. I don't want to take more time. Thank you.
Thank you, Mr. Ramos. I totally agree. Having human intelligence, working with the artificial intelligence, creating what you call augmented intelligence to have higher accuracy, higher, efficiency. And what you said, localization of AI is rather important. I experienced it myself, especially with the use of smart chatbots. Text mining and text analytics is very important. The government or any organization that uses text, and who doesn't? Everybody does. Everybody uses a text in their work. Next will be Dr. Karthik Nandakumar. He will be talking about trustworthiness of AI systems. Dr. Karthik, he is the associate professor in the computer vision department at Mohammed bin Zayed University for artificial intelligence based in the UAE. Prior to that, he was research staff member at IBM Research in Singapore. Dr. Karthik, the mic is all yours.
Thank you, Mr. Ahmed.
You have the presentation ready.
Are you able to see my screen?
Yes, we do.
Okay.
Everybody does? Yeah. Okay.
Yeah, so thank you, Ahmed, for the opportunity to talk to this in front of this distinguished panel. And good evening to everybody. So I am Karthik Nandakumar. As Mr. Ahmed mentioned, I am an associate professor at Mohammed bin Zayed University of Artificial Intelligence. but actually I'm a newbie here. Like I just joined like a couple of weeks back. Prior to that, I was working at IBM Research Singapore as a research scientist. Today, my presentation will be more focused on the trustworthiness of the AI systems. So already Mr. Rand had talked about one part of the trustworthiness problem, right? So the trustworthiness is actually two sides of a coin. So one side is like, how do you use AI to fool people, which is all the deep fakes and other kinds of things which Mr. Rand talked about. And the other part of the thing is like, how can humans fool AI systems, right? So you also need to look into that part. So that will be the main focus of my presentation. Right, so I think there's a lot of discussion on like what is AI and how data computation and algorithms together form AI and so on. So but the key thing which I want to emphasize is so far people have been talking mainly about what is known as core AI. So what do I mean by core AI? So let's say you are designing a vehicle, which the core functionality of the vehicle is to take you from point A to point B. But then that alone is not enough, right? So this vehicle, so let's say you're designing a car, this car must be safe enough, like it should not fail. I mean, it should not cause accidents, it should not cause injury to you, it should not cause injury to other road users and so on. So the core functionality of just transporting one person from point A to point B is what most of the AI scientists have been focusing on for all these years. But now as AI systems get deployed in the real world, people are also starting to look at other kinds of issues. Like, so one is mainly the trust issue, which is like, how do you ensure that this AI system which you deploy is secure, safe, it is fair, not biased, and so on. Right? And then finally, you have all those, you also need to make them scalable in the sense that, I mean, it's not just enough to have a car. So the car might break down, you need to have an infrastructure to repair the car, you need to have the infrastructure to update it, you need the petrol stations to fuel the car, or let's say if you're designing electric cars, you need to have all the infrastructure to power these vehicles, right? So that's all part of the scalable AI part. So far people have been mainly focusing on the core AI stuff, but going forward, issues like trustworthiness of AI systems and the scalability of AI systems, or the infrastructure around these AI systems, will become more and more important. So I'll skip this. I think all of us know that AI is transforming many industries. So the core part of my presentation is like answering these 4 questions, which is basically, are AI systems fair? Are they easy to understand? Are they secure? And are they accountable? By fair, I think many of my predecessors have already talked about how AI systems can be biased because of the training data they use. So how do we address that issue? Like how to make the design an AI system which is not going to be biased against one particular type of people, right? So that's one of the important questions that need to be answered. Otherwise, there is no way these kind of systems are going to be accepted. So for example, when I was working in IBM, there was a bank which wanted to make like credit decisions, like whether to give a person a loan or not based on an AI model. But then they found out that based on all the previous records, if you train a model, then it starts discriminating against certain kinds of people. So let's say if people from particular backgrounds, or mostly women, so it basically says that although they have the same kind of attributes as the men, basically it starts to say that these people are less likely to repay the loan, so their credit worthiness is lower. So how do you design this AI system to take, this is because of the past data, right? This is because of the human bias. Over many years, bankers have their own prejudices when they give out the loan. So because of that, there's like a vicious cycle which gets formed, right? So you basically don't trust certain kind of people, and then those certain kind of people, you make wrong decision, and then they don't repay the loan, and this gets gets into a vicious cycle. And if you train the AI system using this kind of data, the AI system also falls into this cycle. Right? So that's one of the key things which we need to avoid, how to make these AI systems very fair. The second question is, how secure are AI systems? So how easy it is to fool an AI system. So we already saw some examples that how AI systems can generate realistic content that can fool human beings. But the flip side of that question is, can human beings come up with methods which can easily fool AI systems? So I will show some examples in the later slides. And all these things come down to the question of how easy it is to understand this AI system. A lot of these problems can be easily addressed if we know how to explain the decisions made by an AI system. So that forms one of the core parts of the research going forward in the field of AI. And finally, it is this ethics issue of like, how do you make AI systems accountable? So if there's so let's say you have a driverless car and then there's an accident, like who do you make it responsible? Because is it the AI system's fault, or the designer who designed the AI system, or is it the company who sold the driverless car? Like, who becomes responsible for this kind of accident? So these kind of ethics framework needs to be developed in order to make AI systems workable in the future. So most of the examples I'll be showing in the case of face image processing, which is one of the things which I'm more familiar with. But then this thing applies to any general AI system. So the first thing is the bias problem. So the problem is that machine learning is, by its very nature, is always is kind of some kind of statistical discrimination, right? So it's trying to discriminate one type of images against another. So that's how the whole machine learning process works. But then this discrimination becomes objectionable when it places some kind of privileged groups at a systematic advantage or disadvantage. And it also becomes illegal in certain contexts. So for example, in the credit disbursement scenario, which I talked about earlier, so if you, let's say, always discriminate against women or like minority people, then it becomes a huge issue in terms of deploying this system. And most of it creeps in because of this bias in the training data. So this example, which I think one of the speakers already talked about, which is the unequal performance of the AI system for different kinds of classes, right? So this is one of the work from MIT students, basically. They're basically testing a face recognition or a face processing system for the gender classification task. So basically they're giving a face image and want to decide whether this is a male or a female. And they try different systems like the Face++, Microsoft, IBM, Amazon, Kairos, and all these things, right? So what they observed is that the error rate is much higher for females compared to males. The error rate is also very high for people with darker complexion, and it is much lower for the lighter complexion people. So it's essentially biased towards Caucasian male. So if you give a Caucasian male image, it always gives you the correct decision. On the other end of the spectrum, if you give it a, let's say, a black woman, black female image, then basically the error rate is very, very high. So this kind of unequal performance is not acceptable in many application tasks. So one of the key areas of research in AI today is like, how do you address these kind of biases?
2 minutes, Dr. Kathy. 2 minutes.
Sure.
Thank you. Go ahead.
And the second thing which I want to talk about is this robustness of the AI system. So here I want to show some examples. So, on the left side, right, you find an image. So the first column in that image is just the original image, and you basically add a little bit of noise to this image. For the human eye, it doesn't change the image much, but then actually to the AI system, so all these images on the left, they're classified correctly into the correct classes, but all the images on the right are classified as an ostrich, although then none of these images look like an ostrich. The same case with the image on the right. So here you take the same noise pattern, add it to different images, and then you get different kinds of class labels out of it. So this is a big problem. This is just a benign problem, but then you imagine a driverless car driving, and there is a small change to this stop sign, and it actually becomes an yield sign. So it basically will cause an accident. Similarly, you can go and do physical attacks, right? So let's say I paste a small post-it note in this stop sign image, or just a black dot in this speed limit image, then essentially it stops recognizing it as a stop sign or the speed limit sign. So all these kind of things are really dangerous when you deploy an AI system in the real world. And so one more thing which I want to talk about is this biometric presentation attack. So this is again a slightly different problem where for the human beings, all these images look real, but then all of these things are fakes because they are just a printed image shown in front of a camera. Whereas on the right side, all these images look very different, but they are all real. So it's very difficult to distinguish between a printed photo or a photo playing from an iPhone and iPad. Yeah.
Thank you very much. Excellent. Deepfake. This is a deepfake and manipulation of images and biasness of in AI is a great challenge, and we needs to be dealt and treated properly in order to have people have a higher buy-in by the end users. Next, and the grand finale will be with Professor Ernesto Damiani. He's a senior director of robotics and intelligent systems at Khalifa Institute, Khalifa University, based in the UAE. He will be talking about policymakers' role in facilitating the adoption of AI. The mic is all yours, Professor.
Thank you very much. I hope you can hear me. I'm trying to share my screen and just to show a couple of slides. Here we are. Can you see my slide? I will go. Can you see my slides? Well, I hope so. Well, basically, I would like to start by very quickly by.
Can you maximize the screen, please? You know, full screen.
Yes, of course.
Better. Yeah. All right. Great. Thank you.
Okay. So I hope you can see full screen.
Yes.
So, okay. Wonderful. So I would like to summarize a little bit what a couple of things that I heard in the previous talks before jumping to a few remarks on the regulation about AI and how the regulation can foster or not the adoption of AI. So we have been seeing that all these wonderful results are a massive move to some traditional ways of making decisions. And this traditional way of making decisions is not, I'm not saying that it was worse. I'm saying that it was regulated or could be regulated in a different fashion. So basically we had an explicit encoding of some human comprehension or modeling of a phenomenon into, well, a recipe, the recipe for decision making. That recipe had properties, could be verified and tested in some straightforward way. And we built a lot of regulation around that because basically we decided how it was to be tested and audited, by whom, when, and all this was sort of part of the regulations, right? So regardless of the complexity of the technique of the algorithm that could be applied to make a decision in a given context, well, certainly we had a habit of how external authorities, auditors, and even the users would be informed and could be expected this algorithm used to be regulated. Now, what we have seen today and all this all the other talks before mine gave us the idea of this incredible landscape of applications, but all of them have in common the notion that we are training models based on data. So the recipe is a little bit less easy to find in the trained model. And so the regulator, which could put conditions on how the recipe would be computed quite easily in the case of an algorithm, is a little bit at a loss. Basically, the regulatory action may have a problem in finding, the right reference points within the AI in order to be able to foster or to basically limit the use of AI in a given situation. So it's quite easy to legislate about the rating of trustworthiness of people to banks when they are expressed by an index, which is a clear formula. It is a bit easy to legislate about how the algorithm should take a decision on whether to give me a loan or not, if the algorithm is no longer an algorithm, but it is a machine learning model trained on experience, right? So this is this is something that I would like to highlight. It was mentioned in the previous talks. And this is even worse after what I call the 2006 discontinuity. I don't want to enter into that because my previous predecessors already mentioned it. But the 2006 discontinuity was basically the more and more we are going to large-scale models with thousands of hyperparameters and millions of parameters. So the parameters are the internal weights of the model that we are using to make a decision. So that is sort of a jump in complexity, which is sort of given us higher accuracy, but also a little bit more difficult to understand. And what you don't understand is a little bit more difficult to regulate, right? So, for example, I just wanted to show you very quickly a business decision about some maintenance of equipment, which used to be done with a formula like this. And this kind of formula, of course, needs to be calibrated. It's a formula that tells me the decay of a given part of a machinery, and it gives me the expected lifetime of that part. So I can write a rule saying whenever the lifetime is smaller than shorter than a certain amount, you should go in and do something, right? So rules like this are all over the industries, from the telco industry to the transportation industry. Rules like this are basically written by external regulatory bodies in order to regulate the activity. They are quite easy to write about a formula like this. A little bit less when you have something which is basically, first of all, it's more holistic. So it goes based on a number of parameters. And secondly, it is basically something which is derived from looking at the history of that equipment. And so the expected lifetime is basically something that you learn from looking at the equipment in the field. It will give you better accuracy, right? Because the model I showed you before is a little bit hard to calibrate. This one you can also train based on your own data. Use transfer learning to start with a model and improve it based on the local conditions. And we do it a lot of times here in the UAE when we do transfer learning on models that we buy from abroad. But still, you know, the problem is that it's quite difficult to impose a rule that says when the model says this, you do that. Now, and I don't want to enter, this could be repeated, this reasoning, not only for the training, but for many parts of the life cycle. Here I'm showing you the life cycle we put together in the European Network Information Security Agency model for, well, we say regulating on AI. And it is part of what I'm going to say in the next slide, which is basically summarizes the reason why I am here in this panel, to remind you of the normative challenges that the adoption of all the extraordinary results we mentioned will have. First of all, we need to discuss, to have a common terminology. The common terminology is the one that needs to be kept in consideration by the regulatory authorities when they will establish something about the AI adoption. At the moment, we have an ISO committee working, and of course, there's a delegation of the UAE. A few of the local universities are represented in that delegation. We are trying to set up the vocabulary for speaking about the AI in the AI adoption regulations. So this is ongoing work as we speak. So what is an augmented data set? What is a held out data set? What are all these terms that we use? And the regulatory authorities will need to intervene on those and to give us guidance on how to do that. We need the terms. Secondly, well, I don't even want to open it. The IP will, one of the big obstacles to wide-scale adoption of this type of models is to who owns the IP. I gave you my data to train your model. I am the owner of the model as well, just because, well, maybe your model wouldn't be so accurate without my data, right? So when I bring in a model from abroad and I adapt it to the local condition, do I become a co-owner of the model somehow, at least for its usage inside the UAE? So this is another area in which, well, people are at work as of now. And then there is my baby, this is just my personal interest, is certification. I mean, we are going to substitute for example, in medical equipment, a lot of algorithms with machine learning models. Okay, but the algorithm implementation was certified. We had standards. Before we could, for example, in a blood transfusion, automatic needle machine, right, we could deploy an algorithm. Now, if we deploy an AI, we need regulation. Okay, so these are all aspects in which we, technical community, need to work together with the lawyers and with the regulators. If we want to have, let's say, to extract the maximum potential for the adoption of AI. So this is just a list, a wish list of challenges, but of course, these are all challenges we are working on at the moment with the industry, with the university academic part, and with the government agencies. So, well, I hope we will have the opportunity to discuss also this side of the matter, which I believe is crucial for the successful adoption of the artificial intelligence. So this is it. Thank you very much.
Thank you, Professor. Thank you very much. Very, very insightful. Now we have open discussion. It's a bit late in here now. So we'll have open discussion. We have received numerous questions, but we'll take only 2 or 3 max, okay? I'll take one here. To what level would humans can trust AI application? Dr. Catherick, would you like to give us an answer for this? To what level would humans can trust AI application?
Yeah, so currently there are no standards available. So as Professor Ernesto mentioned just now, basically we need to come up with these standards. So it's very difficult to design, say what level, or like we need to come up with all these certification standards and so on to say that, okay, this one is accurate to the X% level, and then this one is robust and secure, because we really don't know. That's a correct answer.
Thank you very much. Another question, which industries are more likely to benefit from artificial intelligence, and what would be done to enhance its pan-sector reach? Anyone? Dr. Rand, would you like to take this?
I'm sorry, can you repeat the question?
Which industries are more likely to benefit from artificial intelligence, and what would be done to enhance its pan-sector reach?
Well, I think, as we've said here, everybody pointed out, most industries will benefit from, this type of automation. The thing that'll help its adoption, on the other hand, is the development of techniques for doing verification, validation, test, and evaluation of the systems. Because right now, such techniques don't actually exist. So this is very poorly understood, and that requires a lot of work and a lot more research. Otherwise, the systems will never be reliable.
Okay, great. Last question. Eco-friendly things, carbon footprint. Many people say AI requires high computing powers. This will lead to carbon footprint. What AI scientists are doing about that? Do you think? I think Mr. Nader, yeah, Nader, I think he has been input in this because, sorry, Dr. Patrick Banger, because you are working on, I don't know, Nader or Patrick, they are working on an algorithm that will, that requires less computing power.
Certainly AI requires a lot of computing power, and that of course generates GHG emissions, which is not good for our sustainability. There are technologies available, and we're developing some of them to do more with less. So there are some software technologies that allow distributed computing to train an AI model on multitude of computers, and because they have access to collectively more memory, you will need less computing cycles overall. Therefore, you will consume less electricity. There are some other hardware technologies available as well. For example, the FPGA, which has a fairly low electricity footprint. But if your model is relatively, moderate size or small size model, you can train them on that kind of hardware and consume less power. depending on where your data center is located, more than half of the electricity consumption is air conditioning. So just simply putting the data center in the right place helps a lot with electricity consumption. And then obviously how you generate that electricity. If it's generated by solar or wind, you're not actually releasing GHG emissions. So you definitely want to push that edge to be more sustainable. So I think there's some aspects that AI can do, but the data center managers, such as us, of course, have a heavy role to play on the hardware side.
Thank you very much. And this will take us to the conclusion. Thank you very much. On behalf of the Director General, Dr. Muhammad Al-Ali, Director General of Trends and the Management of Trends Research and Advisory Center, I sincerely thank all the panelists for their valuable time in participating in our symposium. And we thank the audience for attending and for the questions as well. In conclusion, I would like to announce the announcement that I promised to say in the beginning of the symposium. Trends is proudly announcing the launching of the Artificial Intelligence and Advanced Technology Research Department, with its main objective to provide insights and research papers that foresee the future that is evolving with AI. Looking forward for the next symposium. We have the next symposium will be on November 30th. It is part of the series about the first annual Political Islam E-Forum, Path to Caliphate, the Truth Behind Muslim Brotherhood Project. This symposium is entitled Muslim Brotherhood's Global Journey from Mastery of the World to Hunt for Safe Havens, which will take place again on November 30th at 7 p.m. UAE local time. You can watch this on our Trends YouTube and social media and event webpage. Thank you very much. And we sincerely again thanking you. We thank you and we appreciate your input in our symposium.
Thank you so much.
Hope we'll see you again, guys. Thank you very much.
Thank you, everybody. Thank you.